electronics, interdisciplinary nature of power electronics. You need to know, you need to have a good knowledge about circuit theory, electrical machines which you want to control, and third is power systems. In modern power systems, we don't use conventional techniques of active power control, reactive power control. We use the modern techniques, and these techniques use power electronics technology. Using the power electronics technology, we can very efficiently control the active power, the reactive power, the voltage regulation, and so on. So therefore, you must have the good knowledge about power systems. Then you must have the knowledge about control theory. You must have the knowledge about control theory. See, my dear students, control is the heart of any power electronic system. Most of the power electronic systems which exist in nature, they are closed loop control systems. So therefore, whenever you design a power electronic system, a power electronics converter, a closed loop system, you have to design its controller, and you must know how this controller has to be designed, and what is the, how this controller works. Various types of controllers which you have studied in your control systems courses, like proportional controller, PID controller, and then you can use fuzzy logic controller, you can use neural network based controller, and so on. So control theory is also very important for designing and for proper operation, for understanding the operation of a power electronic system. Then you must have knowledge about semiconducting devices. In power electronics, the control is, any power electronic circuit uses these power semiconducting devices, and these devices are turned on and off at a certain frequency, and controlling the on and off of these devices makes you achieve your goal. Like in case of AC to DC converters, you want to convert AC into DC, or in case of DC to AC converters, you want to convert DC into controlled AC, and so on and so forth. This is done only by properly coordinating the turning on and turning off of the devices. So these power semiconducting devices, you must have a good knowledge about power semiconducting devices, various types of power semiconducting devices, how they act as switches, their turn on time, their turn off time, their losses, their switching frequencies, and all that. So you must have the knowledge about semiconducting devices. And then electromagnetics. You must have some knowledge about electromagnetics, because it is also a part of your power electronics converters operation. Then you must have the knowledge about analog and digital electronics. Analog and digital electronics. Any power electronic system is controlled. Okay, you have to generate the controlling signals for the turning on and turning off of the devices, for the proper operation of any power electronics converter circuit. And these controlling signals or control signals you can generate using analog electronics or using digital electronics. Okay, so therefore these your simple control algorithm for the operation of these power electronics converters you can implement through analog electronics or through digital electronics. So some knowledge about digital electronics or analog electronics, like feedback amplifiers, comparators, monoshorts, etc. You must have that knowledge. Then you must have some knowledge about microprocessors and microcontrollers. You can implement a very simple control algorithm or a control algorithm for operation, for the control of your power electronic circuit, writing programming codes, and you can burn those programming codes into your microcontroller chip, and using that microcontroller chip you can generate the control signals for the control and for the operation of your power electronic circuit, power electronic converter. So knowledge about coding, like for example 8085 microprocessors, it's a part of your curriculum. There you use assembly language programming, and if you want to implement your control algorithm using 8085 microprocessor, you must know how to code. Similarly, if you want to use microcontroller, you must have some experience of writing the codes, microcontroller codes, so that you can implement the control algorithm there. Then signal processing using digital signal processors. Signal processing. Nowadays in market, dedicated digital signal processor chips, DSP chips are available, and you can implement your control algorithm, even if it's a very complex control algorithm for the control of your power electronic system using digital signal processor chips, DSP chips. Okay, there are some dedicated DSP chips which are available in the market for the for implementation of control algorithms for the control of power electronic systems. And finally, you must have some knowledge about modern evolutionary techniques. Evolutionary techniques like artificial neural networks, fuzzy logic, and genetic algorithm, and so on. You may use fuzzy logic controller. You may use artificial neural network controller. Or maybe for the operation of your converter, some optimization technique is required, some search algorithm is required. So you can use genetic algorithm for that. So you must have, if you want to really become a good power electronics professional, then you must have some knowledge about ANN, fuzzy logic, and genetic algorithm, etc. So therefore, this diagram and this discussion clearly shows that power electronics is an interdisciplinary course, right? Now, I'm going to discuss with you the importance and the significance of power electronics in modern era. How important is power electronics in our lives, even in our day-to-day lives? Okay, I'm going to discuss that with you. Importance of power electronics in modern era or modern age. Believe me, power electronics is one of the most important, most significant technology in modern era. Power electronics has already become integral parts of our lives. Whether you know it or you don't know it, you are using power electronics. Simple example is just go to your homes, enter your kitchen, enter your bedroom, enter your drawing room. See everywhere you are using power electronics. How? Where are you using power electronics in your homes? Lighting system, LED bulbs. Nowadays we use LED bulbs, which are highly energy efficient lighting systems. They are based on power electronics technology. Before LED bulbs, we were using compact fluorescent lamps, CFLs. They were also based on power electronics technology. So therefore, it means that in your home, the whole lighting system is based on power electronics technology. Now let's come to the heating. Go to your kitchen. I'm sure many of you in your kitchens may be using induction cooking systems, induction cooking range, induction heating system. This induction cooking system or induction cooking range is an application of power electronics technology. At this time, you will not be able to appreciate or understand where is power electronics used in an induction cooking. In due course of time, as we progress in the discussions of various types of converter circuits, I will discuss with you where this power electronics technology is used in your induction cooking system or induction heating system. So that means heating in your kitchens is also nowadays done using induction cookers, which are based on power electronics technology, right? Now, go use your computer. You are using your computer, whether it is desktop computer or laptop computer. Your computer needs power supply, okay? A regulated power supply. So that power supply is given by power electronics technology. Inside your computer, you have a box. If you open the CPU of your computer, you will see a box of this size, that's called switched mode power supply, SMPS. So it gives regulated DC power supply to your microprocessor chips, say plus 5 volts, and other chips also get power supply plus 12 volts, plus 15 volts, and so on and so forth. So without this regulated power supply, your computer is going to collapse. It's not going to work. Your TV circuit needs regulated DC power supply. That DC power supply is inbuilt inside the TV circuit, and that is based on power electronics technology. The set-top box of your cable and the set-top box of your dish antenna, dish TV, needs regulated power supply. That's again provided by power electronics technology in the form of switch mode power supplies. You are charging your mobiles. What is a charger? It's a power supply. It converts AC into DC, and with the help of that DC, your battery of your mobile gets charged. So that's again the application of power electronics. Again, no doubt it is a low power electronics in this case, but it's the application of power electronics because it gives regulated power supply, right? In your homes, you are using power electronics in other forms. Nowadays, the air conditioning systems which are available in the market are highly energy efficient. How? Which technology has made them energy efficient? It is the power electronics technology, because your air conditioners are fitted with AC inverters. They are inverter based air conditioning systems, and inverter technology is pure power electronics technology, and it makes your air conditioning system highly efficient. The question is, how does an inverter make air conditioning system highly efficient? I will come to that at a later stage. Nowadays, our washing machines are also modern washing machines, refrigerators, and even fans. They are fitted with power electronics technology. And you may be using motor-driven pumps in your homes for pumping water to a water tank, which is at second or third floor of your house. And modern motor-driven pumps are also based on power electronics technology. So therefore, your homes already are flooded with the devices, with the systems which are based on power electronics. So there is widespread use of power electronics in your homes. Go to offices, go to commercial establishments, go to industries. Everywhere, especially industries, they are flooded with power electronics technology. In industries, the machines, the motors are controlled using power electronics converters. Electric traction, electric railways. We don't use IC engines or steam engines. We don't use steam engines in in trains nowadays. We have electric traction. We use motors, and those motors are controlled by power electronics converters. Electric vehicles. Maybe after 10 or 15 years on roads, you will see only electric vehicles, and IC engine based vehicles will be over. You may not use after 10 or 20 years any IC engine based vehicle. You may use electric vehicle. Okay, electric vehicles are also based on power electronics technology. That means your transportation sector is also flooded with power electronics applications. Your utility, electric utility, power generation, power transmission, power distribution, there also you find now a very widespread use of power electronics. Military equipment, defense equipment uses power electronics. IT industry, telephone industry, communications, they use power electronics. Ships, aircrafts, everywhere you use power electronics. Power electronics, that's why I have said it has entered every sphere of our lives, and it has become integral part of our lives. So to add to this, to signify the importance of power electronics, I will say three quotes of IEEE. I hope many of you must be knowing the full form of IEEE. IEEE, it means Institute of Electrical and Electronics Engineers. It's an organization which promotes the research, which publishes the high quality research in various areas in the field of electrical engineering and other allied fields. And they are the journals and transactions of high repute. Okay, there are some quotes given by this IEEE. I call them IEEE quotes, and those quotes signify the importance of power electronics in our day-to-day lives. What is the first quote? I will not write here, because if I start writing a quote, it will take time. I will just speak. I will just tell you about what this quote is about. And since this is a video lecture, you can rewind your video lecture and you can listen to it again and again, and you can note down the quote. The first IEEE quote, which signifies the importance of power electronics in modern life, is like this. So listen to it carefully. This quote says, "We now live in a highly automated sorry, the quote says like this: "We now live in a truly global society. In highly automated industrial front with economic competitiveness of nations, in future two technologies will dominate: computers and power electronics. The former providing the intelligence as what to do, and the latter providing the means of doing it." This is the first quote. So this quote says that in future two technologies will dominate the world of technology, the technological world. Two technologies will dominate: computers and power electronics. You are very much aware of the progresses, rapid progresses which have occurred over the last 3 to 4 decades in the field of computer technology. But how many of you know that a parallel progress at equal pace has occurred in power electronics? Hardly any of you. I'm sure none of you knows. The power electronics, which has now entered our homes, our industries, our offices, our commercial establishments, our industries, our transportation, it's not just a coincidence. It is because of very rapid growth, progress in the area of power electronics over the last 3 to 4 decades, and this progress has been parallel to the progress of computer technology. The two technologies have progressed at the same pace. Okay, and because of a very rapid progress in the area of power electronics, we are now having the widespread use of this technology. That's why this quote says that in future these two technologies will dominate. One is computer technology and second is power electronics technology. It puts power electronics technology parallel to computer technology, right? That is the first quote. Second quote is like this. Listen. Second quote says, "Modern computers, communication systems, and electronic systems get their lifeblood from power electronics." I will repeat. Modern computers, communication systems, and electronic systems get their lifeblood from power electronics. Now, my question is, what is the lifeblood of an electronic system? What is the lifeblood of a communication system? What is the lifeblood of a computer? Unfortunately, I'm not physically interacting with you. It's a video lecture, it's a virtual lecture. So I don't expect an answer from that side. So let me, clarify it. Let me give the answer myself. For the operation of your computer, in your computer, there is a motherboard. On the motherboard, you have the most important chip, that's called the microprocessor chip. And you have other supporting chips like programmable peripheral interface chip and other chips. All those chips, IC chips, they need highly regulated DC power supply. Like, for example, your microprocessor chip requires regulated plus 5 volts power supply. Similarly, there are other chips, supporting chips, which some of which need plus 15 volts, some need plus 12 volts, and so on. So this DC power supply on which your computer works, it should be highly regulated. Okay, this regulated DC power supply forms the lifeblood of your computer. If your computer is not provided with a regulated power supply, it will collapse, it will not work, at all. So its lifeblood is regulated power supply. Similarly, your communication system, in a telephone industry, communication circuits need regulated 48 volts for the operation. Okay, you can search it from the internet. Communication circuits, they need regulated power supply. This regulated power supply is provided by power electronics technology. Similarly, your electronic systems, whether it is microwave oven, your video, recorder, audio recorder, mobile phone, or any electronic circuit, they all are based on regulated power. They all work perfectly, satisfactorily, because of this regulated power supply. If power supply to them is not regulated, they will not work. They will stop working. They will give erroneous operation. unsatisfactory operation, or they may collapse, they may not work at all. So therefore, giving providing regulated power supply to an electronic system, to a communication system, or to a computer system forms the lifeblood of that system. And this lifeblood is provided by power electronics. I have already told you that if you open the CPU of your computer, you will see a box, and that box is switch mode power supply. It gives power supply to microprocessor chip and other allied circuits, other peripheral circuits of your motherboard. And it is because of this regulated power supply that your computer gives satisfactory operation. So power electronics, this is switch mode power supply, SMPS, is an application of power electronics. We'll discuss that in future, what is an SMPS and how it is based on power electronics technology. So this is second quote. The third and the final IEEE quote says like this: solid state electronics brought the first electronics revolution, and solid state power electronics brought the second electronics revolution. Again, very important quote. The invention of transistor, signal transistor, and diode, that was the beginning of solid state electronics, and that was in fact a revolution. And the second revolution was brought when thyristors, SCRs, were invented, and that brought in the second revolution, and that revolution is solid state power electronics revolution. So this quote says that power electronics brought in the revolution. Yes, it was in fact a revolution, and this revolution, its fruits are now being reaped by the humanity today. We use power electronics in every field, everywhere. So therefore, these three IEEE quotes clearly signify the great importance of power electronics in modern day-to-day life. Right. Now let me give you a global energy scenario. Global energy scenario. What is the energy scenario at global level? It is like this. Globally, about 87% of energy needs are fulfilled by burning fossil fuels. So what type of fossil fuels are we burning? We are burning oil, natural gas, and coal. These are the fossil fuels. By burning these fossil fuels, about 87% of global energy demand, energy needs are fulfilled. The rest 6% energy demand is fulfilled by using the nuclear fuel, and remaining 7% by using the renewables. Renewables means hydro, wind, and solar energy systems. Okay, so this is the global energy scenario. That means about most of the energy demand is fulfilled by burning fossil fuels. Same is the story in India. In India, about 70% of energy demand is fulfilled by burning coal in thermal power plants. Electrical power is mostly generated using thermal power plants in India, and in thermal power plants, how do we get the energy? By burning the fossil fuel. And which fossil fuel? Coal. Okay. Now there was one report about 10 years back, 10 to 11 years back, published in one of the IEEE journals, and that report at that time said that in future this nuclear fuel is going to last next 50 years only. Oil, it has a life of 100 years. It will last for next 100 years. Natural gas, according to this report, will last for next 150 years. And fossil fuels, which are the main sources of energy globally, they will last for next 200 years. I mean, this report is alarming. This report says, since there is large, pressure on these fossil fuels, a huge pressure is there on the fossil fuels. We are burning these fossil fuels like anything to fulfill our energy demands. And because of huge pressure on these fossil fuels, it says that after 200 years, we will run out of the stock. There will be no fossil fuels available. Now, the million-dollar question is, will the wheels of civilization come to a stop? Will the wheels of civilization come to a halt after 200 years, which means at the end of 22nd century or at the beginning of 23rd century? Will we go back to Stone Age? I will not be alive at that time to confirm this report, to verify this report. But one thing is clear, that there is large scale depletion of fossil fuels because of huge pressure on these fossil fuels. As electrical engineers using power electronics technology, I can contribute a lot. What I can do, we can extend the period of these fuels. For example, if fossil fuel, they say, according to this report, it will last for only next 200 years. Is it possible to extend this period from 200 years to 250 years or 200 years to 300 years? Yes, we can do it using power electronics technology. How? We can reduce the pressure burden on these fossil fuels. But how? Number one, by using electrical energy efficiently. So use electrical energy efficiently. Don't waste energy. Second is increasing the conversion efficiency. Conversion efficiency should be increased. As I told you that these power electronic systems, they use converters, AC to DC converters, DC to DC converters, and so on and so forth. So if we are able to increase the conversion efficiency of these systems, we'll be stopping, or we'll be reducing the wastage of energy. When we are reducing the wastage of energy, that means there will be less burden on the sources of energy, fossil fuels, and we can extend the period of these fossil fuels. Thirdly, generate electrical energy using renewables as much as possible. As much as possible. Use hydropower plants. Don't use thermal power plants much. Go for alternate sources of energy. Use hydropower plants. Use wind energy systems. Use solar energy systems. And try to generate electrical energy as much as possible through these renewable energy systems. That will, reduce the burden on fossil fuels and other type of fuels. So when the burden on other sources of energy, fossil fuels, is reduced, so their life will get extended, and this will be really a contribution to our future generations. We'll not be alive at that time, but we'll be contributing a lot towards our future generations. By extending the period of these fossil fuels, we can make really a contribution. And here, power electronics plays a very significant role in energy conservation, in conserving the energy. Let me discuss it briefly now. Let me give you a simple example of a thermal power plant. I will draw the schematic of a thermal power plant. This is turbine. This is the generator, which generates electrical energy. This is a step-up transformer, and these are the buses. Then there are various stages of transmission and sub-transmission and so on. And finally, this is the load. A simple schematic diagram of a thermal power plant. This is the front end, turbine, where energy is produced. You have a generator at the generating station. This turbine shaft is coupled with generator shaft, and electrical energy is produced. Let us assume that 100 kilowatt of energy is produced here or generated here. Unfortunately, the efficiency of these turbines is very, very poor. And about 65% of energy gets wasted here at the front end itself, at the turbine end itself. We are generating 100 kilowatts of power, but because there is huge loss at the front end itself, we are wasting 65% of energy. And then there are various stages. There is transmission stage, sub-transmission stage. Power is transmitted maybe over hundreds of kilometers, and on the way we are wasting some power. And finally, say 15 to 20 kilowatt power reaches the load. So how much power are we generating here? 100 kilowatts. But how much power is received by load? Just 15 to 20 kilowatts. What happens to the rest of the power? It is wasted. And most of the power is wasted at the front end itself. So for example, if my load is drawing 15 kilowatts power, that means 85 kilowatts of power are wasted, out of which 65 kilowatts are wasted here, and rest 15 to 20 kilowatts on the way. Now the $1,000,000 question is that if major losses are taking place at the front end, at the turbine itself, why do they tell us that you conserve the energy at the load? You increase the efficiency of your load. You go for energy saving. You're not mainly responsible. You know, major loss does not take place here. Major loss of energy takes place here. But we are still told, you see the advertisements from electrical utilities, from various governments, save energy, save energy. Okay? So if energy is wasted mostly here, why they tell me that you save energy here? The answer to this question is very interesting and very simple. If I save 1 kilowatt of power here, I'm saving 6 kilowatts of power here. Because the logic says that, for example, my load is drawing a power of 15 kilowatts. For drawing a power of, or for consuming a power of 15 kilowatts, how much power had to be generated here? 100 kilowatts. So that means the ratio is 1:6. That means if my load demands a power of 1 kilowatt, I have to generate approximately 6 kilowatts of power here, so that, out of this 6 kilowatts, 1 kilowatt reaches my load. So if I am saving 100 kilowatts here, I am saving 600 kilowatts here. So 1 kilowatt of power saving at the load saves 6 kilowatt of power at the generation side, at the front side. This is the logic. That's why we are told that you save energy. Because if I save 1 watt at the load end as a consumer, I'm saving 6 watts there at the generating station, right? So power electronics has a very significant role here, because it is the power electronics system, power electronics converters, which we will be using, and with the help of which we will be saving tremendous amount of energy. And saving the energy at the load side using power electronics means we are saving energy here. So what are the various applications where power electronics is used for energy conservation? We'll discuss the role of power electronics in conservation of energy. What is the role of power electronics in the conservation of energy? Power electronics, I will try to explain it with the help of some 5 to 6 practical applications where we will use power electronics technology, and with the help of power electronics technology I will try to explain how we are saving energy. Okay, first is motor driven pump. Motor driven pump. Second application is space heating and air conditioning. Space heating and air conditioning. Third application is lighting. Fourth is induction cooking. Fifth is the regulated power supplies. Regulated power supplies. And sixth application is fan regulators. Fan regulators. These are the 6 applications. There are many more other applications of power electronics technology, but I will explain in this lecture and in next maybe a couple of lectures these 6 applications where power electronics can help us in efficient use of electrical energy, in conserving and saving the energy. In today's lecture, I will discuss the first application, motor driven pump. I will again go through this First application where power electronics is used and it conserves the energy is motor-driven pumps. Second is space heating and air conditioning. Third is lighting. Fourth is induction cooking. Fifth is regulated power supplies. And sixth is fan regulators. Let me take the first application in today's lecture, explain how power electronics helps in energy conservation using this application, motor-driven pumps. Motor-driven pumps. Why do we use pumps? We use pumps for pumping the water at our homes to say second or third floor in water tanks. And main application is for agricultural purposes, where pumps are used for pumping of water for irrigation purposes, for agricultural purposes. Okay, now these motor-driven pumps, if you take conventional motor-driven pump, traditional or conventional motor-driven pump, it looks like this. You have a motor. It is connected to AC mains. If it's a single phase motor, the single phase 50 hertz to 30 volts. If it's a three phase motor, it will be 415 volts, three phase at 50 hertz. Depends. Then this motor is coupled to a pump. So this is your pump. This is the pump. This pump has inlet and it has outlet. This is outlet where from water comes out. And here this circle with cross represents throttling valve. This is a valve, simple valve. How does this pump, what is the prime mover for this pump? A motor, electric motor. When the electric motor starts running, it runs the pump and then pump sucks the water. This is the inlet where from it sucks the water, and then this is the outlet. Now the flow rate of the water is controlled by throttling valve. I mean, if you need more flow rate, you open this valve more and more. And if you need less flow rate, what do? You close the valve. इसकी opening आप कम करते हो. When you close the valve more and more, the outlet flow rate decreases. And if you want more flow rate, you open the valve. So opening and closing of the valve controls the flow rate. But the problem is that irrespective of flow rate, what is the flow rate? How much you have opened the throttling valve or how much you have closed, how much is the flow rate, motor draws same amount of power. At full flow rate or at high flow rate, whatever power motor is drawing from the supply, same power it draws when the flow rate is very, very low, when you are closing the valve. So opening of the valve or closing of the valve or high flow rate or low flow rate does not change the power drawn by motor from the supply, because your motor runs at single speed. It's a single speed motor. Okay? And at constant speed, it draws same amount of power. So therefore, for example, when flow rate is high, you completely open the valve. So motor draws power from the source and it pumps the water. And when you need less amount of water, you decrease the flow rate, you close the valve. But motor draws same amount of power as it was drawing when flow rate was high. So therefore, there is a lot of wastage of power, wastage of energy at low flow rates. At low flow rates, your motor should have drawn less power because your flow rate is less. But it is drawing same flow rate as it is drawing same power as it was drawing at high flow rate. So therefore, it is wasting a lot of energy. How will power electronics solve this problem? How will it help in the conservation of energy? Let us see. So what power electronics will do? It will use adjustable speed drive. Adjustable speed drive. This is again supplied by AC mains. And then this is your pump, As usual, this is the inlet, sorry, and this is the outlet. And there is no throttling value. You don't need now throttling value for controlling the flow rate. You don't need it. Okay. Now, what is this adjustable speed drive? This adjustable speed drive comprises of a variable frequency inverter. I will write here. It's a block. This block actually comprises of variable frequency inverter plus motor, AC motor. I have shown it in a single block. But this block actually comprises of an inverter, a variable frequency inverter and AC motor. Actually, what happens? You have an inverter first. You have AC mains at 50 hertz. Then that inside this inverter, that AC is first with the help of a rectifier converted from AC to this AC is converted into DC. And then with the help of inverter, this DC is converted back into AC but variable frequency. Here frequency was fixed, it was 50 hertz. Here frequency is variable. You may vary the frequency from 5 hertz to 50 hertz. It's a variable frequency output. And you have studied in your induction motors, one of the methods of speed control of an induction motor is frequency control. Because the speed of an induction motor is given by ns times 1 minus s, whereas s is the slip. And this ns is 120 f by p 1 minus s. What is this f? It's frequency. Therefore, when you are controlling the frequency, you are controlling basically the speed of motor without changing its slip. Highly efficient way of controlling the speed of motor. So therefore, what will this adjustable speed drive do? It will provide AC supply to the motor. Motor is inside this. It will provide AC, variable frequency supply to the motor, and by providing variable frequency supply, it will adjust its speed according to the flow rate. For example, let us suppose we need high flow rate, large water out at the outlet, high flow rate. Now what will this inverter do? It will automatically increase the frequency of the output. Therefore, the motor receives AC supply at high frequency. Okay, and at high frequency it runs at high speed, and because of high speed the flow rate is high. And if you want low flow rate, then what will this inverter do? It will decrease the frequency of the AC supply, and when the frequency decreases, the speed of induction motor decreases, and at low speed the pump's flow rate also decreases. Are we using any throttling valve, any mechanical arrangement for controlling the flow rate? No, it is electronically done with the help of inverter. Inverter automatically adjusts the speed of its output voltage or output power and gives variable frequency supply to the induction motor, and induction motor speed is automatically varied according to the flow rate. For high flow rate, the frequency is high. For low flow rate, it decreases the frequency. There is no throttling valve. Therefore, for high flow rate, the motor runs at high speed and draws large power, more power. And at low flow rate, the motor runs at low speed, and at low speed it draws low power, less power from the source. So therefore, there is no wastage of energy. Whereas in the conventional motor-driven pump, irrespective of what was the flow rate, the motor was running at same speed, rated speed, on speed, and at low flow rate, it was wasting the energy. Whereas in this case, using power electronics, that is variable frequency inverter, the speed of motor automatically gets adjusted according to the flow rate. And at low flow rate, the speed of motor is low and there is less power it draws from the source. So therefore, it saves tremendous amount of energy. And I will repeat with the help of previous diagram where we have seen that 1 kilowatt saved at the load end causes 6 kilowatt saving at the supply end or the front end. So therefore, with the help of modern motor-driven pumps using power electronics, variable frequency inverter, we are removing the major losses which are there because of the presence of throttling valve. This is a single speed motor. Here we have a variable speed motor, and therefore there is conservation of energy. So this is one application where you have seen how power electronics saves energy, it conserves energy. Inshallah, in our next class, maybe tomorrow or day after tomorrow, I will explain other applications which I have already enlisted and you must have written those applications where we will see how power electronics helps in the conservation of energy, in the increase in the efficiency of the system. So with this, I will end my today's lecture. I request all of you, my dear students, listen to this lecture. I will upload it by tomorrow on my YouTube channel. Download the lecture, watch it, and listen to it carefully. And while listening to this lecture, you can make the notes also. Try to understand. It's a beautiful technology, power electronics technology. You will really enjoy it. The only thing is that you should have interest in learning this technology. Learn this technology, make the notes, study it, download the material, more supporting material from internet, and read this subject, study this subject. Any doubts you'll have? We are already on Google Classroom. You can discuss with me, or we have already have that WhatsApp group. Any doubts you can put on that group, or you can even put your doubts on the comment section of YouTube. I will definitely try to clear those doubts. Stay at home, stay safe. Thank you very much. All the best.